This is part of a problem-solving lecture series in investments. Today we will have a look at problem 11 in chapter 2 from the 10th edition of our textbook. Here's a view of this problem. Let's go ahead and highlight some key facts provided in the problem. We are given three stocks, and basically those stocks are A, B, and C here, the first three rows, and the letter P represents the price, whereas the letter Q represents the quantity of shares outstanding at time t. For example, the first column would give you the price at time 0, and the second column would be the quantity at time 0. So therefore, what I would personally do is to split this table into the following groups. So basically, we are given three periods. The first two columns would be period 0 here, the second two columns would be period 1, and the last columns would be period 2 here. In part A of this problem, we would like to calculate the rate of return on a price-weighted index. So that's very important. This is not a value-weighted index, it's rather a price-weighted index for these three stocks as we move from period 0 to period 1. So all we do to solve this problem is to calculate the value of the index at period 0 and compare it with the value of the same index for the following period, and as a result find out what the rate of return is. At period 0, the value of the index would be simply equal to the sum of their prices divided by 3, because we are given 3 securities. So the prices during period 0 were 90, 50, and 100. 90, 50, and 100, all divided by 3. We would get $80 as the value of the index at time 0. The same index at time 1 is equal to, let's call the first one as index 0, the second one as index 1. So therefore the prices now in time 1 would be this column over here. It would be $95 plus $45 plus $110, all divided by 3 again. When you have the sum, it would come out as $83.33. So therefore we can see there's an improvement in terms of the value of the index. The holding period return, or the rate of return for this index as a result would be equal to $83.33 minus $80, all divided by the initial value of $80. So therefore the difference of these two would be simply $3.33 divided by $80. We would get simply 4.17%. Make sure to have a calculator handy, and then that you can get the same result as well. Okay, in part B now, we would like to find the divisor of the index, of the price-weighted index in year 2 basically. Well, obviously the significant event that happened in year 2 was that stock C had a split in the ratio 1 to 2. So each stock split into 2, and for the other stocks you can see there is no change at all. So therefore, because of that stock split, we are expecting the divisor to change. In fact, we're expecting it to fall, as is usually the case when firms split shares. So the best way to handle it would be to think about before the split. If hypothetically there was no split here, what would have been the price? Well, it would have been $110, right? So that would have been the price, and as a result, what would have been the outcome? Well, the outcome wouldn't have changed, huh? So in that particular case, we can quickly calculate the index value in the absence of split here at t is equal to 2. We get the index is equal to pretty much like what we got in the first period, pretty much the same result. We would get $95 plus $45 plus $110. Now, this is a hypothetical number, as I suggested earlier, for a total of $83.33. And here, obviously, the divisor is 3. So let's make it clear here. The divisor is simply equal to 3. Now, after split at time 2, well, it must be the case that the new divisor would divide the numerator in such a way that the value of the index is indifferent. So therefore, index at 2, well, we know that is already $83.33 is equal to $95, which is the price of stock A at time 2, plus $45, which is the price of stock B, plus the price of stock C, which is simply $55. And now, instead of dividing by 3, we will divide all by D, the new divisor. So therefore, all we will do is solve this equation for D. So one thing we can do is find the have a 1 here, invisible, and then do a cross product. Doing the algebra here, I leave it to you guys as a homework. The the divisor, the new divisor would be 2.34, and that's not a surprising result. As I suggested earlier, we were expecting the divisor to be lower, as is usually the case when stocks split. And finally, part C. The question is basically asking for the rate of return for the second period as we move from period t is equal to 1 to t is equal to 2. We can do something similar as we did in part A, but for this particular case, there's a kind of a shortcut here. We can just observe that the price for stock A as we move from period 1 to period 2 have not changed, and the price for stock B also as we move from period 1 to 2 also does not change. Well, seemingly the price for stock C changes, but it is purely due to the stock split. In the absence of a stock split, the price during period 2 would have still been 110. Realizing that the return of each stock separately is still equal to 0, meaning there is no change in the prices, we know that the return would simply be, the rate of return I should say, would simply be equal to 0, as we explained a few minutes ago. So that would be 0% because prices have not changed. If you didn't make that observation, all you would have done is, like in part A, you would have calculated the index for period 1 and also index for period 2 and look at the rate of return calculated, but you will get the same 0% as I suggested here. And that solves our problem. Hope to see you in our next video.